Starting with UniFi Network Server Application version 9, you can start using zone-based firewall rules. Zone-based firewalls provide a flexible, powerful way to secure your network by grouping interfaces into zones and defining policies for those zones to control the traffic between them. So let's get started, or should I say, let's get into the zone. Are you an individual or forward-thinking business seeking expert assistance with network engineering, storage, or virtualization projects? Maybe you're part of an internal IT team that needs to proactively manage, monitor, and secure your technology. We offer comprehensive consulting services tailored to meet your specific requirements. Whether you need fully managed or co-managed IT services, our team is ready to help you. We specialize in supporting businesses that require IT administration or teams seeking an extra layer of support to enhance their operations. Our install team is ready to assist you with all of your structured cabling and Wi-Fi planning needs as well. To learn more about any of our services, head over to lawrencesystems.com, fill out the Hire Us form, and let us start crafting the perfect IT solution for you. If you want to show some extra love for our channel, check out our swag store with shirts, hats, desk accessories, and more. We also have affiliate links down below that'll get you discounts and deals on products and services we talk about on this channel. With the ad read out of the way, let's get you back to the content that you came here for. I want to start by defining what zones are. Zones are where the policies live for those networker interfaces that are within them. The zone policies control the traffic of those interfaces within that zone or between zones. You have a rule set that you build, and there are some predefined ones we'll be talking about here in UniFi for each of those scenarios. And if you move a network from one zone to the other, the zone policies don't follow the network, they apply to the network. So if I were to take a network and move it to a different zone, it will then have all the policies of that zone, but I wouldn't need to make any other network changes. So this is a easy and powerful way to define things because you only have to define the policies on a per zone basis, and then you assign as many networks as you want to that particular zone or interfaces. Now I say or interfaces, and someone may be pedantic at this point, leaving it in the comments that technically zones apply to interfaces because it's not applying to the network, because it's not controlling the inter-host traffic for a particular network, and you would be correct. It is the way UniFi labels them as network interfaces. It's still accurate, but for those of you that are more pedantic and very detail oriented, yes, you're technically applying it to the interface because for each network, there's going to be an interface defined for that network. And that's technically where the rules are because hosts automatically can talk to each other without routing through the gateway when you have a host in a subnet with other hosts. Allow return traffic. This is something for people who've come over from the FreeBSD world where they use the PF filter, may have an extra rule that you may be confused by. Implicit return traffic under PF filter. When you create a rule in PF to allow outgoing traffic, it implicitly allows the corresponding return traffic for that connection. You don't need to create a separate rule for incoming traffic. But under the Linux IP tables, which is the underlying technology in the UniFi firewall, explicit return traffic rules. To allow return traffic for connections initiated by your system, you need to create explicit rules in IP tables. These rules typically use the contract module to track the connection state and match the return packets. This is automatic in UniFi, but they do have a checkbox if you don't want it to work. Normally you do, and it's default checked when we're creating rules that are going to go between zones. I just want to point out why that rule exists, because if you've come from the FreeBSD world where PF filter is used, you'll say, well, I didn't need that rule before, and I don't understand what this extra rule is, and does it create a security problem? It's only allowing return traffic that was initiated from one zone to another. Now let's talk about the predefined zones that exist in UniFi and how those rules work before we get to creating a custom zone. First, we have defined here external, gateway, and VPN. These zones are defined zones right out of the box in the system. So WAN and UniFi, when it's a client, goes in external. You can set up UniFi Firewall to be a client to connect to something like a privacy VPN or a site-to-site VPN. And if it's the client doing the connection, it lands in the external zone. Gateway is the IP or interface of the UniFi system itself. And of course, because this is the firewall, it's going to have gateways that are at each one of the different subnets that you create. And this is where those rules are that control access to the UniFi system, including like the admin interface, or in the case of the UDM Pro that I'm using, you have the ability to have it talk to the UniFi Protect server. So this is where you'll have all that control for the unified devices, the ports they talk to, the admin interface that's on 443, SSH is on 22, and I'll talk about how we define those rules. Then you have UniFi as a VPN server. As a VPN server, there's another zone that just dedicates the rules to go there that is applies to a server. So if you're connecting via OpenVPN or WireGuard and inbound to the firewall, that goes under that zone. Now we have the internal zone, which is a default allow to all zones, including but not to the hotspot. So it includes everything. So you want to put, and this is where UniFi will put the default networks that you create is right in the internal zone. That's where my computer lives as an internal zone. It gives me access to everything except for hotspot. Hotspot we'll get to in a moment, but this is an allow all zone to talk to all the other networks that are also in this zone. So if you add several networks and are all in the internal zone, they all have the ability to talk to each other. So I create this other subnet, I can have my computer that's in the internal zone talk to other networks that are also in that internal zone. Then we have the DMZ zone. This allows external access. This is a place, in DMZ is a long-standing term in the firewall world for demilitarized zone, where you say, all right, this is where something I want to host and open up external access to will live. I can, from the internal zone, get to the DMZ, but the DMZ cannot initiate a connection to me. You're self-hosting a mail server, a web server, something publicly exposed. The risk you're trying to mitigate is if someone comes in and gets to that particular server. By the way, all rules are blocked on WAN, so you do have to open up ports to do that, such as doing a port forward. But you want to open up a port, you're hosting a web server, and then something happens to that web server. You would be concerned, of course, for lateral movement of how do they get back to internal safety zones. Well, they can't. The DMZ by default blocks that. But if I need to admin one of those servers, I can get to that zone. Now, this has the allow return traffic. It does, though, block access to things like the interface on the gateway. So if someone were to get into the DMZ or have something connected there, they won't get to the web interface of the UniFi itself or be able to SSH in. It also blocks other networks that are in that zone. So if you have a DMZ with a defined subnet and several more defined subnets or networks that are all in there, they can't talk to each other, but from the internal zone, you'd be able to talk to each one of those different subnets that are in the DMZ zone. Hotspot and internal. Now, internal, same rules apply like I said before, but I can't get to hotspot. Hotspot allows external, no gateway, blocks all their networks in the same zone. It is a dead end, and that is a great place for put things that you're worried about. There's just by default, and you can override any of these zone policy rules, but there's by default no way for it to talk to anything else on the network. So hotspot's a good place for things like a guest network. It has no access to the gateway. It just is allowed to leave the network and go out to the internet. End of story. That's where it stops. If none of the predefined zones work for you, you can create custom zones. So I have this zone called NSFW nets, not safe for work networks. This is where I put other things, such as my Chromecast and a few other devices. We'll talk about what goes there. And the nice thing is when you create a custom zone, it is secure by default because they have a block rule, and you have to start adding rules to allow things. This is a good security posture to start out with. Will keep you out of trouble, so you're not necessarily adding networks that are wide open. So you do have to create some rules. By default, the NSFW net wouldn't have been able to talk at all to the internal zone, or I should say the internal zone can't talk to NSFW. So either one of those are blocked, and you have to create rules for things you may want to allow to go from there to other zones. So if you just hit create and say yes, it's not going to have a lot of rules in it. So I have this as custom defined, and we'll cover that in custom defining them. To get to the zone policies, we're going to go to settings and then the security tab. If you have not converted, the system will prompt you to do so. It even lets me know when I did the conversion on this particular system, which was on February 5th. I converted, and it has an automatic backup. And you can restore the previous configuration by going all the way back there. Not what I'd want to do, but you then collapse this because I don't need to look at that anymore. Then we have different ways we can select the zone. So I can click on internal, and I can see what networks belong to those zones. And I can change if I wanted to and move my lab into this zone and just check the box, hit save, and they'll move over. Same thing if I wanted to go here, I can click edit and move one of those zones over. For example, I have these zone test ones we'll be using, so I can hit save and hit apply, proceed. And now the network that was up here has moved down to here, the zone 2 test network. And if I wanted to move it back, I can go back to edit, and I want to bring it back over into this zone, hit proceed. And now that network's in this zone, which means all the different policies of the internal zone apply to each of these networks. You can also go to networks and click on any of these tests and choose what zone you'd like to move it to. So I could do the same thing here. There's different ways to do it. And when you're in the network settings and you create a new network, it defaults to internal, and you can choose the zone at that time at the creation of the network. This doesn't affect addresses or any other settings of the network. It just affects what zone policies are going to apply to that particular network. Now, when creating new zones, you hit create the zone, give the name. Then you can select the networks that you want to go into that zone, and we'll hit save, add entry, proceed. And now we've created a test zone. And as I mentioned earlier, here is the rules. From test zone, it's going to block internal because you have the source over here and the destination across the top. So test is going to block to internal, and test will block to test. What that means when you're blocking itself is if we were to take this zone here, we'll actually hit edit, and we're going to go ahead and move this one in here as well. Hit save, apply, proceed. These two separate networks in this zone cannot talk to each other, but they can route out, because if we look at the policies here, there is a block invalid traffic, but allow all traffic. So that allows this zone to head out of external, but we have policies that do allow it to talk to the gateway, versus if we were in the DMZ zone, it has only rules to allow to talk to certain things such as MDNS, DNS, ICMP, get a DHCP address, but not actually talk to the gateway. So even though it is a block all rule in terms of the other zones and its ability to get to them or devices to get to the new zone you created, it will have access to the gateway, something to keep in mind when you're creating the zones. Also worth noting, when you create a new zone, but then delete that zone, what about the networks that were in it? Let's go ahead and do that. We're going to go manage, remove, proceed, and it's going to throw them back over to internal. So if I were to delete any custom created zone, which you can only delete custom created, you cannot delete the built-in zones, it will automatically throw those zones over here into your internal network. Now let's talk about zones, policies, and a few things that may be a little bit confusing at first. First, where do things go? Well, I've decided TomLAN should live in the internal zone. Internal zone allows it to talk to other internal zones that I create, and for demonstration, I created zone 1 and zone 2 tests. We'll be playing with these later. Now, this also means internal zone can talk to VPN, and VPN can talk to internal zone. Maybe you do, or maybe you do not want this. I prefer it because if I'm VPNing into the system, I want to be able to get to my internal TomLAN network where my devices live. But you may have policies you want that stop that, but I'm the only one with a VPN, so I don't want that. The other thing that can be very confusing is I mentioned earlier about HotSpot not allowing to be talked to from internal or from HotSpot to internal. So even though it says allow all, I want to show you how the dynamic rule creation works, because there's an assumption that I had when I first looked at this that internal and hotspot would be able to talk to each other. So let's go ahead and go to the hotspot, and we want to select the zone 2. We want to move it over. Now, what you're seeing here is dynamic rule creation in action because it happens pretty much instantly here. Hit save, we're going to apply, proceed, and suddenly there's policies in place. What these policies do is block all traffic, allow return traffic, but then have these post-authorization restrictions. This rule is created automatically. These are not rules you can edit, and this blocks the RFC 1918 addresses. So the rules don't exist until something is in there. So until you put a network interface into one of the zones, it does not have these policies. So it looks at first like it's going to allow, but those policies actually block that from working. Let's go ahead and take this, edit, and move the zone back. Apply, proceed. And all you see is the return traffic rule, which would allow return traffic if something came from one of the zones and back. So I just want to point that out, that did confuse me. And if it confused you, that's because the policies don't exist if there's nothing in there. And I'm not using the hotspot, so there's nothing in that particular zone, hence no rules. Now the DMZ does have allow return traffic, and you do have these two networks in there, and that does work. This is just a simple allow traffic rule. So when I initiate a connection from internal to DMZ, it is allowed to reply. Now, this is an important one right here, is external. I have my primary WAN. And of course, we want to have anything that accesses the internet to be able to go out the WAN or the secondary WAN, but I also have the privacy VPNs and my CNWR Toledo. That is our Toledo lab, Toledo office. I want to have the UniFi acting as a client. So if we go over here to VPN client, we have the Toledo lab connection, which I don't want everything to go out. I'm not as worried about the privacy VPNs, but we're just going to block everything, and I'll show you how that rule works. This is the different tunnel IP subnets, and access to those subnets that are attached to external allows things to go out those connections. Now, the first step is going under Profiles, Network Objects, and I created an object called RFC 1918, and I just listed all these RFC 1918 addresses. Also under Profiles, I have the UDM management ports, which is port 443, 22, and 80. This is the web interface and SSH for the UDM management. We'll use that in a later rule. Now, the custom rule I have is block RFC 1918. This is a block rule where source zone is the DMZ, the action is block, destination zone external, object, and we can choose that object we have right here, the RFC 1918. I could have just typed them all in manually by IP, but I prefer to put them in as a single object. And then we're going to scroll down and you'll see that it just says block DMZ zone from client VPN. This stops anything from that DMZ zone from being able to go out that particular network and have access to things that are attached to the external. And I've got that same policy again under my not safe for work. It is the top rule. Rules work from top down. So I have block RFC 1918, and it's the same thing. I don't want anything on not safe for network where I have things like my Chromecast and a few other things to be able to use that network. Now, if I wanted one of these to use a privacy VPN, then I could put a rule above to allow a single device access to one of those subnets that is the privacy VPN. But I don't want to, so it's just going to have a block rule at the top here. Now, as I mentioned earlier, DMZ has rules against the gateway that only allow certain services to access the gateway, MDNS, ICMP, DHCP, and allow return traffic. So if the gateway reaches out to a device, it can talk back to it. But when you create a new zone, and now we'll get into all the policies that are in the NSFW nets zone, the allow all traffic is a default rule. So the networks that are within this particular zone have full access to the gateway. And this is where we want to do a block UniFi management. Now I could block everything and then only allow the same rules as the destination, but I didn't feel like being that granular because I just wanted to block the UniFi management. And also because I have the UniFi Protect camera devices in here, I wanted them to be able to talk to the gateway and not have to sort out each rule. But if you want to be much more restrictive, yes, you can get much more granular. But block UniFi management is blocking the source of the not safe for work nets, the zone here, and destination gateway, as in the gateway itself, the UniFi firewall. And we've just chose the object, the UDM ports. These are those management ports 22, 80, and 443. And it's just a simple block rule to stop any of these networks from being able to talk to the gateway in terms of those management ports. Now, the reason I have the UniFi Protect devices in their own network and not tied to the internal zone, but a separate zone, is because frequently you'll find these devices, especially cameras, you're putting on the outside of a building or an outside of a house. And what if someone were to pull a camera down and plug a laptop in from the outside? Would you want them to have access to things? Probably not. So we have them locked down this way. Now, home things is in here, which is just the home network devices where the phones are and where the Chromecast is, so I can cast things onto the Chromecast. And that is also where just my friends who come over to connect to that network to be able to also do things like watch TV and cast to the Chromecast. Then we have CamLAN. Now, I could have broke this out to be separate, but you can get granular with the rules for a particular zone because CamLAN is a bunch of random cameras of different brands and the Synology DVA that talks to them. Now, I want the Synology to have access to the internet. So if we go here to the policies for NSFW Nets 2 external, we have that block RFC 1918, which means don't talk to the privacy VPN or the Toledo lab. Those are all blocked. But then we have allow DVA to the internet. And the reason this rule exists is because I want the Synology DVA to have external access, and you can choose things by device. So I chose the device. Now you can choose multiple devices here. The nice thing about choosing things by device versus choosing them by IP, if I ever move this network at all, the device rule would still apply as long as it was within a network inside this zone. But this allowed me to create a rule to say that Synology DVA can get out to the internet. But then I have block internet from source zone NSFW-net, and because CamLAN lives within that zone, and I could choose other networks if I wanted, I'm going to say that network shouldn't have the internet. So we just have a block rule that says, nope, that rule says only this network is not allowed to go out. You could, as I said, create a separate zone for this and put that network in the zone, but for simplicity, just one extra rule saves me from creating an entire another zone. Now, when we look at the not safe for work networks in the internal zone, we have a couple policies that allow very specific things to happen. We have once again, a Synology DVA. I say I want that to be able to talk to the Synology RS1221. So we start with the zone of the NSFW network. We have the Synology DVA again, shows as the device. We have allow, and we do have this check, the allow return traffic rule to allow the traffic to return. And then we go down here and we have the two different devices. HA is Home Assistant, and that lives right here at 172.16.16.12. And this is the Synology RS1221. These are things that I'm allowing because Home Assistant talks to the Synology DVA, and it's allowed to, but the Synology DVA needs to send a webhook over to Home Assistant in order to trigger different events. I've covered that in previous videos. So this rule allows for talking to these two devices. I could get more granular where it only is allowed to use exactly the ports I want, but I've decided to just allow the system to talk to these two IP addresses. I'm not too worried about what it will send over to them, but if you wanted to get very granular, absolutely you could. Now let's demonstrate a little bit of testing, because although I trust that these are properly set up rules, I always prefer to verify that I have the rules set up properly. This is where the Zone 1 and Zone 2 tests come in. I have a system in each. So this is in Zone 1 and this is in Zone 2. So this lives in those particular networks, and those networks are currently in the internal zone, as you see up here, which means if I go to ping Zone 2 from Zone 1, it works. And if I ping Zone 1 from Zone 2, that works as well. Let's go ahead and clear these. The other thing I want to mention is both of these are going to have access to the management interface. So the gateway IP is 10.22.22.1, and I can see the SSH, HTTP, and HTTPS ports on here because that's where Zone 1 lives, and the same thing here. This is on a completely different subnet. So this is 10.22.22.1, and this is 10.23.23.1. But once again, we have access to all of those management ports. So let's go ahead and move these and put them in the NSFW net, and we'll just move Zone 2. So we'll click on this. We're going to go to Edit, and let's take Zone 2 and save, apply, proceed. All right, now it's moved over. By the way, when it moves over, it shows in the UI immediately. The rules take probably 2 or 3 seconds, sometimes a little bit more. So if you notice a lag from where you can still ping something, it's because it takes a moment to apply the rules. It doesn't take too long, but just something to note. So now that Zone 2's moved to the NSFW, as I noted, we have a block rule, which means it can't talk to the management interface. But of course, this one still can because we left it in the internal rule. But if we go to ping Zone 2 from the internal zone to Zone 2, which currently lives in the NSFW zone, as we see right here, but the opposite, if we wanted to ping Zone 1, well, the NSFW net's not allowed to reach back out. Even if you're doing a reply, just for clarification here, when this is reaching out to Zone 2, that only means Zone 2 can respond to what Zone 1 initiated and not what was initiated from Zone 2, because that's the way the traffic rules work. Now, hopefully this gave you a good understanding of how to create the zones, how to put the networks into zones and create the policies and understand the rules in between them. But this is the controversial part that I know a lot of people will be asking. Tom, you said you had your Chromecast or other devices you cast to with your phone in the same network. Surely you can't put this phone network in with other IoT devices. This is my sacred device. That is something that I've always struggled with, where people don't think of their phone as an IoT device. Many different services. Sonos is one that comes to mind. I don't use them, but I know they have issues when you cross networks. Lots of things expect, if you're operating them from the phone, Chromecast is an easy example, that the device will be on the same network as the Chromecast. And I'm just not worried about someone somehow remotely taking over, as in Google, sending bad commands down to the Chromecast to laterally move over to my phone as an attack vector. Seems pretty unlikely, but if that's something you are concerned about, definitely separate them and deal with the challenges of getting the phone to talk to the Chromecast across the network with MDNS, and hopefully it works consistently. But generally, when I find people having a lot of buggy problems with it, it's just because the design and architecture of many of those devices are expected to be on the same network to work flawlessly. It's not that you can't get them to work. It's just that if you want them to work well, you kind of have to go with the design expectation, and it just seems a little bit unrealistic. Now, what about some random other IoT devices? Well, mostly I don't have many of those. I do have a couple Roombas. Once again, I'm not worried about them attacking my Chromecast and phone. If you are, though, definitely take your Roombas and put them on a separate network. I just don't have any other IoT devices to separate, but if I did have like just random things I bought off of, well, Temu or Amazon, yeah, maybe those do belong on a separate network, but most of those devices, the IoT ones that only need internet, I would throw them in the hotspot zone because they just need to go out, and most of the time, those are applications where you're reaching out with some app that comes back into your network. They're not trying to broadcast on the same subnet. So those are little details that might matter. And as I said in the beginning, this is something to definitely take into consideration. Yes, when things are in the same subnet, they can talk to each other, and that is something that would be controlled by ACL rules. And there are some future updates coming to UniFi to give you more granular control over ACLs when things are within a subnet, but that is not what's covered by the firewall zone video I did today. So that'll be something in the future. If you want to see me do that video in the future, like and subscribe so you can see that and other fun content I have coming up on the channel. Hit me up in the forums at forums.launchsystems.com to have a more in-depth discussion about this or other topics, and head over to launchsystems.com where you connect me with on whatever socials you'll find me on at the time you go there. And thanks. Launch Systems thanks our sponsors for their support.